Hello, and welcome to today's GTC session presented by DDN. My name's Kuckein, and I am Vice President of Marketing here at DDN. And today I'll be talking about how our AI infrastructure supports NVIDIA's pod and SuperPOD deployments to make AI development much simpler, easier, and manageable, despite the immense amounts of data and processing performance that these kinds of applications require. And so we all know that AI is being used by many companies as a strategic initiative in ways to speed up and create differentiation in the market. Right here we've got this statistic from a Deloitte survey where 90% of adopters say AI is critical to their business success. Now, along with this critical development comes a whole raft of challenges when it comes to data management. And we have new complexities that are emerging. So number one, it takes a long time to develop an AI solution. And if you don't have the infrastructure in place that allows you to scale quickly from POC to production and from iteration to iteration with the right kinds of data in the right place, ready to process it quickly, you're just going to make your development times even longer. But to speed up those processing capabilities often takes complexity that really is beyond most enterprise IT administrators. And what DDN and NVIDIA have done is develop reference architectures that remove a lot of that complexity and ensure fast development time. These reference architectures also come in increments that allow you to scale with success. So you don't have problems where you're trying to go from POC to production to really big successful implementations that might challenge traditional infrastructures like those that are based on NFS storage. And finally, we have things like adapting to new business cases. So being able to do all sorts of complex types of workflows, as well as regulatory challenges. And AI data is becoming a target of nefarious actors as well. So you have hacking coming in there. And so you need something that is truly secure and adaptable so that you can balance the need to protect that data with the need to share that data within the organization. And so what DDN and NVIDIA have done is create an infrastructure that really allows you as an IT shop to create a center of excellence for IT and AI. And it allows you to create this AI center of excellence that makes consolidation and management of data much, much easier, allows you to iterate very, very quickly with high performance GPU processing from NVIDIA with their DGX systems and high performance storage from DDN, which keeps those GPU systems constantly filled to capacity in terms of their processing performance. And finally, you have a secure, agile, and adaptable infrastructure that allows you to grow exactly how your business is going to grow. And the proof comes in the pudding, of course, right? But developing AI infrastructure is hard enough. And often what we're seeing challenging our customers is the fact that data scientists are out there implementing AI under their desk with their own system, processing that data locally, but not sharing it with anyone else in the organization. And you've got multiple people all around the organization doing this. And without a real good span of control from the IT shop, and then also without really being able to truly realize all of the innovative approaches that could be happening if that data was consolidated. I mean, one of the biggest things with AI is being able to make connections with disparate data. And if the data is spread either on data lakes elsewhere in the organization or under somebody's desk over in the corner, the data is not going to be available for those algorithms to be able to make those connections that people are just not able to see. And so these solutions that DDN and NVIDIA have developed together are ready to deploy, fully integrated, fully tested, fully validated. And it is the DDN architecture that really makes this work and work at scale, right? It's the parallelization of I/O along with scalable data management within a single namespace that makes sense for these really large scalable challenges that people are encountering with AI. And finally, these systems are backed by unrivaled experience in dealing with data at scale, whether it's the folks at NVIDIA within the DGX team or DDN's own support and services, being able to deliver systems and maintain those systems functioning 24/7, 365 with the best experience possible for our customers. And so DDN is well known at being an at-scale system provider. And of course, right, we've been working with NVIDIA with their SuperPOD architectures, but we also have our own pod architectures, which allow customers to start with as little as one system and be able to scale seamlessly from there with smart building block units that allow them to scale from 1 to 2 to 4 to 8 to 20 to hundreds of DGX systems. And DDN storage grows right along with it seamlessly. And that's compute, networking, and storage, all available in a turnkey deployment backed by the AI experts and ready to meet all of your future requirements. So what makes A³I from DDN the ideal solution for NVIDIA's SuperPOD? Well, I mentioned one thing already, which is the parallelization that we do to be able to achieve maximum performance on those DGX systems. But beyond that performance angle is that our A³I solutions are modular appliances that allow you to scale that performance as you build out your DGX systems. And as your needs grow, these systems and reference architectures can grow right along with you. And we're the only company that has reference architectures that grow from a single system all the way into hundreds of DGX systems. And our excellent combination of price performance and efficiency in terms of power allows you to really minimize the impact on your data center and your overall budget in terms of allocating money to storage. Now, of course, right, as data grows, you're going to need scalable capacity. We also have the ability to build in automated hybrid tiering so that customers can use all of the power of Flash and our parallel file system to drive performance very, very quickly. And then a scalable backend with a single namespace, always accessible for customers and their users within that one file system to be able to access petabytes worth of data, but keep that data on more cost-effective spinning media. Again, automated tiering, all within one namespace. So even when an end user goes to access files that are months or even years old, they're online and they're ready to be sent back to the customer. And there's no intervention required. Those files can even be restaged back to Flash if that project is going, again, into some new kind of training or iteration mode where you need high performance. Next, we'll get into a couple of case studies where our customers are using either pod or SuperPOD infrastructure to accelerate their research or business. And I'll also talk to Eric Dumans from the University of Florida, who has implemented SuperPOD. And the University of Florida is looking at extending beyond the traditional science and mathematics classes and into every single part of academia to help students prepare for an AI future. And so I hope you stick around for that conversation because it's very informational, even above and beyond the infrastructure that they're using there. But first, I want to talk a little bit about Recursion and their pursuit of new pharmaceuticals using AI and AI infrastructure. Recursion has actually been a DDN customer for probably over 18 months, but just recently implemented SuperPOD. And they are doing drug discovery by augmenting their research using wet labs to identify new treatment paths with AI and one of the largest databases out there to help them synthesize compounds that might not have already been linked together. And they are doing really practical work and changing people's lives by discovering new drugs and new methods of treatment. But recently they were challenged with the pace of innovation that they were doing and the amount of data that they were managing, especially since they were trying to manage a lot of that in the cloud. And so they came to DDN and NVIDIA to figure out if there was an on-premises situation that would actually save them money and speed them up. And in fact, there is. So using SuperPOD backed by A³I, they can repatriate their data from the cloud using DDN's tools and bring that into an environment that is going to speed up both data capture as well as data analysis. So all phases of workloads are now faster, and they have complete governance and can trust the security within their own system because of the multi-tenant nature of DDN's A³I. They can even work with that same infrastructure with multiple partners and keeping that data secure and segregated from each other. And so their SuperPOD is actually projected to deliver a 20x cost savings over 5 years and accelerate their pipeline with those new capabilities. So not only are they saving money, but they're also going to be able to innovate faster. Another use case we have is a large hyperscaler that is pursuing natural language processing, right? And everybody's trying to refine these natural language processing algorithms so that they really behave as truly human. And so the amount of data, again, and the amount of processing was challenging them. Their GPU infrastructure was underutilized, so they weren't getting all of the utilization that they thought they should from their GPUs because their storage was underperforming. And then they also had bulk storage that was not directly accessible within the single namespace. It was off on some object storage that required manual intervention from administrators anytime they wanted to pursue older data that had perhaps gone cold, but now they needed to resurrect to be able to run new algorithms against or refinements against. And so by implementing A³I, we were, number one, able to do this very, very quickly. And that's one of the huge benefits of these reference architectures that DDN and NVIDIA have developed together, is that these things can be implemented in weeks instead of the typical months that it used to take to implement supercomputing capabilities. Now you can roll them from the docks into the IT lab and get working very, very quickly. And you also cut out all of that planning ahead of time because you have these building blocks that are well known and well qualified. So you know the kind of performance that you're going to get because of the testing that we've performed, as well as how you're going to be able to scale these things over time because you have all of that information. We were able to drive full I/O saturation into those GPU systems, and we were able to allow them to scale easily to exceed their targets that they were looking for as their algorithms got more complex and their data sets grew. And one other benefit that you get from the parallelization that DDN delivers is that cold data that is sitting on spinning media is still immediately accessible from the end user perspective. There's nothing that needs to be done to bring that data back, right? As I talked about earlier, that data is automatically migrated via automation. So there's no administrator intervention, there's no user intervention. And then even when the users want that data back, it's immediately accessible on the spinning media. And depending on policies, that media can again automatically migrate into Flash to be used with the best performance and lowest latency. And then finally, I want to talk about NVIDIA's own supercomputing, their Selene system that uses DDN storage behind it. And what their challenge was is they needed a high performance but energy efficient platform that was capable of a wide range of different workloads. It didn't matter whether it was lots and lots of small files or even lots and lots of really large files that required high bandwidth. DDN systems are built to really handle all kinds of complicated workloads and the metadata associated with that. And they needed easy horizontal scalability as they grew the system over time. They needed to be able to grow with it, have that single namespace grow very, very simply and seamlessly as they scaled the number of DGX systems. And they needed to have it delivered and installed very, very quickly. And so what we were able to do is achieve a huge increase in their output by delivering maximum performance all the way to the GPUs and boost that data scientist productivity. We provided a modular, easily scalable platform that scales out over time as they grow their needs. And we were able to deliver a system that can be taken from the dock, placed into the data center, and be up and running and serving supercomputing level performance in 4 hours. And the long-term benefit has been that we now have a very close partnership, but also we're able to learn new things with NVIDIA, with them as customers and users of our systems that allow us to innovate on our own side much, much faster and deliver the capabilities that are needed to people doing AI in all kinds of markets. And so with that, I'm going to kick it over to my conversation with Eric Dumans and myself about what University of Florida is doing with their SuperPOD and how that really applies to basically everything in people's lives and how AI is going to change everything for their students and for all of us. So I hope you stick around for that. And then I will get back here with a few summary statements at the end. So thanks for joining us, Eric, here at our video for GTC, where we're talking about use cases with NVIDIA's SuperPOD and DDN's A³I solutions. Just to do a quick introduction, you are the Director of Information Technology for Research Computing at University of Florida, as well as a scientist in the Department of Chemistry and the Department of Physics. Is that correct?
That is correct. That's correct. I'm a computational physicist is my background, and now I'm a computer science scientist and administrator.
Cool. And I think, you know, one of the most interesting things that I find when talking with you is really the application of all of this, leadership level computing to areas outside of maybe some of the traditional areas where they've been applied, Department of Chemistry and Physics. So we'll get into that in just a little bit here. But maybe you can tell us a little bit about the SuperPOD that has been deployed at the University of Florida, a little bit of the history behind it as well.
Yes, so the SuperPOD at the University of Florida is the result of a donation from one of our alumni, Chris Malachowski, who went on after graduating from the University of Florida to be one of the founders of NVIDIA. He really was interested in giving the University of Florida a supercomputer, and he shared this vision with the provost of the University of Florida and other administrators at the University of Florida of creating a platform and an infrastructure and an environment to really make a big difference in training and educating the people for this coming world where AI is going to be all over the place. And the vision is to create what is called the AI University. We want all the students to be educated and be aware of AI and know how to use it. So the SuperPOD it's a standard configuration that was designed by NVIDIA, and it consists of 140 DGX nodes. And the DGX node is highly optimized. This version, the DGX A100 node, was announced in May of 2020, and it has 8 GPU cards in it, and they're all connected by an NVLink so that all the cards can talk to each other and essentially at speed that which they can process the data, can receive and send data to other processors. So the specialty of the DGX node is that it's very different from you just buying a server that has enough slots and enough electrical power to put in 8 GPUs, right? It's different.
And is GPU computing kind of new for you, or within the supercomputing space at University of Florida, had there been other GPU deployments prior to?
We did have GPU deployments, and University of Florida has been operating a supercomputer for its faculty since 2013. And we had GPUs for a long time, but we noticed that 2 years ago, all of a sudden the demand for GPUs massively increased. And so we bought some low-end GPUs, but now with this donation, we really are proud owners of a top-of-the-line system that can do GPU computing.
And with that also comes a requirement for storage, of course. And I think you were familiar with DDN even prior to the acquisition of this SuperPOD, but DDN was selected as the storage provider for this as well.
Yes, and that is actually another of those features. It's not just that the nodes are very capable and support this collaboration of all the GPUs in it. The whole infrastructure of the SuperPOD is architected so there are 8 InfiniBand connections that go to InfiniBand switches to connect all the nodes with each other, and there are 2 dedicated InfiniBand connectors that go to a separate set of switches to connect the storage system, which is provided by DDN, so that data can be moved in and out of storage to any of the GPUs, again, at speed. So that's why this architecture is highly tuned to deal with the largest problems that you can imagine right now.
Yeah, and so we've worked quite a bit with NVIDIA to make that implementation as seamless as possible so that these types of architectures can be made available widely to institutions and businesses of all sizes. And with that in mind, I think maybe we do want to transition a little bit from the system and into kind of the uses for the supercomputer at University of Florida. And I think one of the biggest things that is interesting to me is the broader application of the system to fields of study outside of the traditional, either just developing AI algorithms or, maybe physics and some of the areas that you specifically have studied in. But also to some of the social sciences and things like that.
Yes, indeed. So, as I already mentioned, one of the driving things that excited the donor was the idea of creating a truly pervasive and comprehensive curriculum. So the notion is that every student, when they go through the University of Florida, whatever discipline they pick, they will have part of their courses infused with some AI knowledge and training so that they know how to use it and how it can be applied, whether you're studying religion or social sciences or history or the English language, or whether you're in the more traditional fields like engineering or science. All of them will know how to use AI in the business school. But then there is also another aspect that makes the University of Florida sort of an ideal place to do this. The University of Florida is a very comprehensive university in the sense that we essentially have a strong presence in any field that you can imagine. We have a strong agricultural school, we have a big medical school, we have a veterinary medicine college, we have we're a land grant university, so we have a big agricultural college that operates in all 67 counties of the state. And so we do a lot of work that requires all kinds of activities, and everybody is very excited to sort of see how AI can help. And that's sort of one of the interesting and exciting things about AI is that it is so, in some way, unifying. It is almost like a universal tool, a little bit like a Swiss Army knife in some sense, that it has been proven to work very well. And of course, initially the breakthroughs came into image recognition and then in natural language processing. But now people are inventing ways to apply AI for all kinds of complicated problems. And so what happened is the vice president for research uh, made a solicitation last summer, and he basically asked everybody to write a short proposal with some funding promised, where people would sort of write down an idea and then ask for funding for 1 year to develop that idea a little bit further so that it could be the basis for a strong proposal to any of the traditional funding agencies like National Science Foundation, National Institutes of Health, the USDA, Department of Defense, Department of Energy. And so unexpectedly, he received 133 proposals. Now, typically when he makes a solicitation like that, he gets around 40 proposals. And he had anticipated 20 awards. Now we got 133 proposals, which really shows how excited everybody is about the idea, and they're all trying to explore it. And I was part of the review committee, so I read all of them. And we selected 20 to get the full award. And the award consists of two things. One is funding up to $50,000, typically used for a graduate student or a postdoc to actually do the work. And in addition, an allocation on this new donated SuperPOD so that they can do the calculation. So they would be provided the hardware and the infrastructure and the support from my staff to actually bring their project to fruition. But because the proposals were such high quality, we actually awarded we didn't have enough money to award all of them $50,000, but we did award them allocation on the system for another 75 proposals because they were all high quality. So the majority of these proposals, 95 out of the 133, were really very good, and they go all over the spectrum. There are people who were trying to figure out economic impact and using AI in that. There are others in trying to eradicate bias in some of the processing for like job applications or image processing. Lots of interesting proposals where people are trying to improve like image processing. Everybody knows that AI can do image processing, but now we want to use that to improve the human performance. Like one beautiful example from the School of Dentistry, if you get an implant, it is very important to find out exactly where the nerve is in your jawbone so that when you drill, where the implant will be screwed in doesn't get too close to the nerve, because that would then result in an implant that constantly hurts. But the humans, in recognizing these images, these X-rays, are not necessarily the best in recognizing where the exact boundaries are. Some of these photographs, depending on the density of the bone for different individuals, it's very different. The boundary is not that sharp. And so there's a proposal where people want to use AI to improve that, so that the AI could point out certain features, and then still a human would make the final decision, but they would be aided by the AI. Another is in agriculture. Of course, if you take some satellite pictures, or you take some drone pictures flying over a field where there's a crop growing, you can easily recognize that if half of the trees are having damaged citrus, then you'll recognize, yeah, that crop is bad. What you want is to find very early on if there's like 1 or 2 trees somewhere, so you can find them and then go and eradicate them so that they don't spread through the rest. And again, image recognition is important there. And what you want to do is not just use the images from the drones or the images from the satellite. You want to merge them all together and have some AI process them and take as much information as it can, something that a human typically cannot do in a timely manner. But with an AI, and especially with a machine like the one that we have, this becomes feasible. So it goes all over the place. It's very exciting.
Yeah, very, very exciting. Yeah, and I can imagine, right, you're trying to integrate all this kind of disparate data from all sorts of different sensors. You mentioned this agricultural instance. I can imagine, right, you have also sensors in the soil, air sensors, all sorts of other things, combining all of that data, making for a really diverse, probably collection of data and difficult data patterns, right? And so can you talk a little bit about why, GPUs and the DGX systems, along with the storage, are particularly well suited for these kinds of data versus maybe other computing types?
Yeah, well, this is sort of an interesting evolution. The GPUs were, of course, developed, everybody knows that, over multiple decades to create very realistic gaming environments for high-end gamers. But then some decades ago, scientists discovered that the kinds of computation that you have to do in order to create a physical model of reality, like weather prediction or image processing or whatever, is very much the same as what these GPUs are doing to create a very realistic looking world for the game to move in. And so with AI, that also became confirmed, that the kinds of calculations you have to do for one of these complicated AI problems are ideally done on a GPU. Furthermore, AI is something that has been in people's dreams for 30, 40 years, as long as there have been computers.
Yep.
But what has happened is there were several things where people said, oh, this is promising. But sometime around 2007, for the first time, people realized that in order to make AI work, you have to have lots of data. You have to have a complex model with a lot of parameters, and you have to have lots of data to fit those parameters. People originally were thinking with hundreds of parameters or thousands of parameters, and they fed it tens of thousands of data points, and that was just not enough, not even close. Now people are talking about hundreds of millions of parameters in a model, and they send it terabytes of data. That's when you get really good results. And that's where the GPU just shines. And that's why the GPU is important. But that also means that you then have to have a good infrastructure to move data to the GPUs and to store it, and it needs to be stored fast. You cannot just put it on some old runky disk drive. It needs to be fast. And so that's where you have to have really top of the line storage, a fast interconnect, and lots of GPUs.
Beyond the kind of just the storage and the processing, are there other considerations that you have either now or in the future around maybe the security of the data? Some of the things, are you doing anything interesting with that? Given that AI data, can contain perhaps some sensitive information. Are there processes that you have in place, or even beyond that, are there things about the architecture of the SuperPOD itself that facilitate that?
Yes, so this is something where the University of Florida has been working on for the last 5 years. And it's a trend that I think is going to increase. Everybody is sort of aware that we are in a state of cyber war. There's a lot of data that some criminals are after, and they need to be protected. And bad things happen when data gets leaked and to unauthorized people. So more and more regulations are put in place to do things in a secure way, in a provably secure way. You can never make it 100% secure, but you can do your due diligence.
Right. There's a big tension between being able to share all of this, right, and all of these resources and protecting that data.
And so we have architected a system that is fully compliant with some of the very rigorous regimes for cybersecurity. And that system actually has a dynamic boundary that can extend, not today yet, but it's our plan in the next set of months to make sure that this new SuperPOD can be enclosed in that umbrella of security so that people can work on restricted data. And that is, of course, something that's going to happen more and more. The most obvious example is precision medicine. People are dreaming of being able to do much more accurate diagnoses that are specific to individuals. Well, if they are specific to individuals, they're going to have some personally identifiable information in them, which means it's covered by HIPAA, and you have to make extra precautions to keep it safe. And so more and more people are going to want to mix public data with specific restricted data, which then contaminates the whole thing that you are going to feed to your AI. And so that more and more of these environments are going to require to be compliant. So another thing that we're going to do is make sure that the entire system is HIPAA compliant.
AI at the current iteration is not without some of these complex concerns around ethics and things like that.
Yes, indeed. At the University of Florida, and I think this is a little bit serendipity, we have an institute that was created a couple of years ago to actually focus on the ethics in AI. And so that's as a foundation. And now the provost has required that every college, when they are setting up their curriculum and courses, include part of explicit training and education on bias and how to consider ethics issues. Because one of the things that is realized, we need to make sure that the engineers who just focus on the performance of the AI are fully aware that when they create their algorithms, these algorithms can have bias. And they are the only ones who can sort of control that. You cannot create an algorithm and then sort of publish it or make it available even under certain license terms. And then just say, oh, if it turns out that it has some bias, then you're responsible for fixing it. Because clearly that's impossible. Once the engineers have designed it, it's going to work the way it works. And there's no way that a user, even if they are very aware of bias and ethics and are the most sort of diligent person, they're not going to be able to change it. So it has to be the engineers themselves who need to develop specific algorithms that can test an AI system while it's being developed. Does it have bias? And then these tests are going to be a little bit like the security measures that you're going to put in place. You're going to also have bias tests, and you need to certify before you're allowed to publish or make your algorithm available to somebody else for practical use. You have to prove that it doesn't have bias. And it's the engineers who invent the new algorithms that have to be fully aware of that so that they do it and they build the right Thanks.
Well, thanks, Eric. I really appreciate you taking the time today to talk with us about the system at the University of Florida. Definitely looks like the institution to be leading AI data storage provider, right? DDN is happy to see all of these new use cases outside of maybe some of the traditional ones, right? We're very familiar with life sciences, autonomous vehicle development, financial services, but going to other parts of the economy and society and figuring out how best to apply AI to augment what humans do today.
Well, thank you very much for having me. And yeah, it's very exciting. So thank you.
So I hope you found the conversation with Eric as fascinating as I did. And I just want to provide a few summary statements about DDN and our ability to scale with you on your AI journey. And it's via our experience and expertise deploying these systems across different markets. We've done so in FSI, in academia, in hyperscalers, for autonomous vehicles, all sorts of different markets who are dealing with really challenging data elements. And we've taken all of that experience and capabilities and packaged it into systems that are ready to deploy today into standard IT environments. And what you see is that people who maybe aren't experienced in supercomputing are maybe a little taken aback by the challenges that they're encountering when dealing with AI data. And what DDN provides is really the simplicity that's needed to integrate into those environments and then being able to scale them as necessary. In fact, just recently, we were talking to a financial services customer who had implemented NVIDIA's pod architecture along with DDN, and they were surprised by the fact that they didn't even need a storage administrator to be able to administrate this AI environment. They really just needed an AI architect who now was able to have span of control over all of this information that used to be located under individual data scientists' desks. And they were having to do their own IT administration. So you had something like 20 IT administrators out there. And now that's all been consolidated into one person who has a span of control and is able to manage the data in a way that makes sense from a security standpoint for a financial institution, as well as have infrastructure that really is enterprise class and able to sustain their development 24/7, 365. And so you get that building block that moves from your early vision and into deployment. So you have the governance that you need for your data, and then you're able to use those systems to share in a multi-tenant way across your business and even between businesses, so that that information is ready for anybody who needs it. What DDN's really delivering is intelligent infrastructure for the world today. And the world is undergoing fundamental transformation with AI and all of that data that we've been collecting over, really the last couple of decades. We've seen this explosion in data, and now there's really something we can do with it. And so if you have DDN systems, you really have a simplified path to implementing AI infrastructure if you're using AI to differentiate your business. If it's really something that's going to fundamentally allow you to change how you're researching, change how you're approaching customers, change markets, and do it in a way that nobody else is doing it today, then DDN's A³I is right for you. It comes fully tested and validated with our partnership with NVIDIA and NVIDIA Mellanox. You get the entire infrastructure, compute, networking, and storage all in a single package that comes in very, very quickly, is easy to deploy, easy to manage, easy to scale. and is backed by the expertise that NVIDIA and DDN both carry in this area. And you get all of that unique capability that I talked about with the parallelization, the single namespace, the automated tiering, and then also just this year at GTC, we announced a new UI that allows you to really examine the entire data path. It integrates in with your DGX infrastructure. It allows you to monitor the GPUs, the network, and the storage in one space so that you can quickly pinpoint and isolate any workload that is causing issues within your infrastructure and be able to provide it the infrastructure that it needs to be able to succeed, or be able to tune that application or algorithm to be able to behave in a way that does not overly impact your entire infrastructure. So thanks again for joining my session today. If you're interested in other DDN sessions, please check them out over here. And go ahead and visit ddn.com/A3I to find out more about our A3I systems. Thanks again. Hope to see you soon.